Hello, and welcome. Welcome to Ngwasheng Maths Online Academy. My name is Desmond Ngwasheng. I'm your maths tutor for this channel. Please subscribe to be able to watch more videos to come. Today we are doing grade 8. This is strictly, grade 9. We are doing grade 9, whole numbers or number system. In this channel we are doing the accommodate grade 8 up to 12. Grade 8 up to 12. However, the previous videos, if you were following us, we started with grade 12, then we did grade 11s, we did grade 10, we're now doing grade 9. Then just after this one, then we're doing grade 8. However, we know that grade 8 and 9, somehow the interlinked, they share the same syllabus, slightly different here and there. Hence, I'm saying, no matter this is based on grade 9, it also accommodates grade 8. So now, this is what I'm going to do today. I want to simplify things. That is the whole plan. Like, the whole plan is to make sure that I simplify things. Most learners fail because, I don't know, there are many factors behind that. But one of the factors is when you misunderstand the point that the teacher is trying to raise. As a teacher, I might try to explain the concept to you, only to find that maybe I make it to be more complex. Now, I'm trying to simplify. Now, let's not waste time. Definition of numbers. All right, definition of numbers. This is what we have. We are going to deal with this. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. This so far is what we are going to do. So I'm going to try to define everything, simplify it, then we can be able to go to the table. Now, this table, like I can tell you, in every examination, you come across this. Like, that is the easiest way for the examiner to present questions based on number system or whole numbers. For you just to identify what this number is under all this. But let me just explain before we go there. Natural numbers denoted by the letter N1. Because in the examination, they won't have time to write the full weights like this. Never. They use these letters. This is what they're going to use in exam. It's very rare to find a table with full weights, natural numbers, whole numbers, integers, positive integers, and all that. Usually they just they're going to write only the letters or this notation that they are using. Now let's see. Natural numbers is represented by N1. Why N1? Because natural numbers are for counting purposes. They are counting numbers. We use them to count. And yet they start with 1. When we count, we start with 1. How many tables are there in class? 1 will count. 1, 2, 3, blah, blah, blah. Continuously so. That's for counting. Hence N1. Now, you know now this is natural numbers. What about NO? What about Z? What about Z plus? Everything Q. Let's come here. Whole numbers. It's NO. We know that whole numbers, they start with 0. Most learners, they know that whole numbers start with 0. But they are also referred as the counting numbers. How so? They are also referred as the counting numbers. Now, but however, it also depends. It depends. What are we counting? We can count by means of measuring something. I can count number of steps. Like maybe I try to measure this whiteboard. I don't have a tape measure or anything. I can measure by the steps that I'm taking from here to there. So the position that I'm at right now, it's 0. But the moment I take the first step, I'm counting. So where I am, it's 0. That is the 0 we are referring to. I'm still counting, but the 0 is also involved. But in this case, no. When we are counting things like human being, class, whatever, that's when we're using 1. I cannot point a person and say 0 and go to the next person and say 1. If I'm counting human beings, learners in class, 1 will be used. So hence we accommodate 0, but in a different scenario. So whole numbers are also referred as the counting numbers. I hope this is clear. So, but the difference between the two, whole numbers only start with 0, however natural start with 1. Done. The next one, if you didn't understand, or maybe I'm too fast, you can always go back. My good people, please make sure you subscribe, like, share, comment. Yes, that is the only platform for communication between me and you. All right, integers. What are integers? Integers are natural, actually both natural and whole numbers together with their negative numbers as well. We agree that natural numbers is 1, 2, 3. Now they say integers are actually made up of natural numbers, whole numbers, and their negative. Part of natural numbers is this 1, 2, 3. Part of whole numbers is equal to 0, because 1, 2, 3 also is there. And also their negatives. So if this is 1, 2, 3, their negative is -1, -2, -3. But hence here is the example. This is a perfect example. If I say -3, -2, -1, these are the negative numbers. What about their positive? Is 1, 2, 3. Remember, now this part here, 1, 2, 3, it's a natural, right? But from here, 0, 1, 2, 3, it's now whole numbers. And I've got the negative. I just answered this, that we have natural, we have whole number, we also have the negatives. Bear in mind that they're going to ask question in this way. Now, since integer is z, some they use they pronounce it as z, doesn't matter. Different teachers, different pronunciation. However, we try to deliver the same thing. I didn't charge. All right. Now, the z, we've got 3 different here. This is just the integer, which consists of both the negative and the positive, and the 0 as well. That is integer. It's like everything under one umbrella. But once we start to separate, when we say z plus or z plus, that is mean I'm referring to the integers that are only positive. In this case, the integers that are only positive, obviously, that is the 1, 2s, and 3s. But the moment you say negative integers, we are referring to the integers which are negative. So you can see which ones are negative. Okay? Now, what about the q? Obviously, q is part of the rational. And q prime is irrational. These two are the opposite of each other. Now, what are the rational numbers? They say these are numbers that can be expressed as a fraction. Point number 1. They can be expressed as a fraction. Now, what is a fraction? Fraction consists of a numerator over a denominator. However, we've got quite different types of fractions. Because even a decimal is also a decimal fraction. We've got a mixed fraction. So, but now let's try to understand. It can be a fraction, yes, but when it comes to the decimal expansion, it ends. That means you will find a number that is a decimal, but it just ends. It's not those decimal numbers that is too long, it's just continuously so 4, something, right? It just keep on expanding, maybe until infinity. It doesn't end. So other way is that rational can be written as a fraction, and the decimal part of it ends. Maybe I can say 1,4. It ended there. It's not 1,432 whatsoever. It's just 1,4. It ends. And then it also repeats. This part of repetition, you come across a number where you say 0,33333. That's how you will see that is also part of the rational because of the repetition. So it means there are two things here. You might find it doesn't repeat, but it ends. Sometimes it doesn't end, but it repeats. The same number more often after the comma. Now, here are the example. 5/2 is part of the fraction. 6 can also be written as a fraction, and 6 will be our numerator. And then, okay, to write the example of the part where it repeat, I can have something like 1 over 3. As you can see, that is the repetition that we are talking about. However, when it comes to the irrational, it's the opposite of that. They say it cannot be expressed as a fraction. So if it happened that it is a decimal expansion, it's a decimal basically, it doesn't end, yet it doesn't repeat too. It's something that will just continue. You can see here, this is a continuous number, but when you say it doesn't end, it means it continues. And there's no repetition. If you check, yes, one can say now I see a 12 there. It's only those two numbers, but it doesn't repeat itself. Now, with that being said, let's look at what we have. Let's look at what we have on the table. Now, apart from this, now we know this is natural numbers because they start with 1. This is whole numbers, they start with 0. And the Z is for the integers. It takes both the negative and the positive number. But only here is the integer that is only positive. He's focused on the positive integers only. Now these are the integers that are negative. Now we are having this Q for rational. As long as you remember what rational is, what irrational is. So my advice, because this is for exam, strictly. Imagine they teach you all this, they'll give you activity, classwork, whatever, homework, activity, but at the end, this is what they are preparing you for. You know the instruction of this in examination? How are they asking question of these problems? They'll take you to complete this column by ticking whatever that corresponds with any of this. In short, is 2 over 3 a natural number? Some instruction, they will allow you to cross if you say no, tick if you agree with that. So my advice is, if you want to score a lot of marks here, start with the obvious. Always start with the obvious. What is it that you know most? Now if you check 2 over 3, are we using fraction for counting? Because now you know N1 is for counting. Are you using a fraction like this to count? Have you done that before? Are we using it? If you find that the answer is no, you know for a fact that you cannot tick that this is part of the natural number. Instead, you rather cross. But in most cases, they just want you to tick the relevant answers only. Where you don't have to say, I know this one, no, it's not a natural. This one is not a whole. This one is not an integer. And it cannot be a positive. As long as it's not an integer, it cannot be a positive, it cannot be a negative. Is it rational or is it irrational? Now, if I want to answer all this, I'll start here to know. But remember, all this is something that you need to know, because in exam you won't have this to help you. So I know most learners 1, 2, 3, they do understand. They just switch these two mostly. So that means you don't have much to work on. Just work on the two to make sure that you don't make mistake. You memorize them thoroughly. Now let's start to work on that. Let's go back. I'm gonna use different colors to actually say no to the one that I feel like is not suitable. Like, I'll start here. This is not a natural numbers. I cannot use a fraction to count. We explained. So it's no. It cannot be for natural numbers. It cannot be part of the whole number as well. Look what they said about integer. Nah, this cannot be part of integer, whether it's a positive or it's a negative. It cannot be. Now, let me tick the one that is suitable. I'm gonna use different marker. Now, we take this as yes. Now, this is a irrational. What do you remember about irrational? Look at the example of irrational. They also indicated that it can be expressed as a fraction, where we are having a numerator over a denominator. What about irrational? In this case, it cannot be irrational. Now look at that. All right, that is the first problem. Pause the video and work on the rest. I'm gonna continue with the same thing to say, let me identify the one which are not applicable and the one that are actually applicable to what we're given in the column and the row. Now, let's come to let's come to this one of 1,25. I'm gonna start by crossing. When we cross, the question that you should ask yourself as a learner, since this is natural numbers, are we using a decimal number for counting? If your answer is no, that cannot be a natural number. Never. You can be arrested for that. All right. Something that cannot be a natural, cannot be part of the whole, because these two, they interlink. They are both for counting. So this one is also a no. Integers, we know it takes both the negative and the positive, but it has nothing to do with decimal. So I cannot take this. And once it's not integer, it cannot be a positive integer. It's not even part of that. Right? Now, the argument can be between the last two, rational or irrational. Now, you should memorize that. Now I'm teaching is you can refer here on this definition. But remember, this won't be there in your examination. Bear that in mind. Now, when it comes to rational, the keyword that they mention here, they say expansion end. It end here. So it can end or it can repeat. So in this case, it's not repeating, but it just end. 1,25, it end there. So suitable enough to become what? Irrational. So again, we consider this irrational. And then for now, we cannot consider it as both. If it's not rational, then it cannot be. If it is rational, it cannot be. If it is irrational, it cannot be irrational. Oh, my mark. All right. Now, let's come to this one. Let me use the red. Where is the red one? Now, C, which is square root of 16. Square root of 16. We don't judge it as a square root of 16. But what is the square root of 16? We are getting a 4. Now, whatever we do, we now look at 4, not longer as square root of 16. Yes, they have a tendency of giving you that. Just like this one. We know what is 25 over 5. It's 5, but they didn't just want to give you 5. They have to give you like that. So be careful of such. Now, we judge 4, no longer square root of 16. Now, let's come to 4. Is 4 part of natural numbers? Yes. Remember, natural numbers are for counting, and there's no way that if I count, I can skip a 4. This dot means continuous, so even 4 is part of it. So I will say yes. 4 is part of the natural numbers. What about whole numbers? Yes, it's also part of the whole numbers. Because even here, if I proceed, after 3 comes 4, while I'm talking whole numbers. Now, I think you are having the idea. Even though in examination, they always like to say, cross the relevant answers. Our learners are so creative, we know. They'll just cross everything. I mean, they will only tick everything knowing that one of them will be correct. So now we want to make sure that you no longer do that. You tick what is relevant. So we assess everything step by step. Okay? What about Z? What about all these 3? 4 is a positive number. It's still part of the integer. Remember, integers is negative and positive. It doesn't mean that since I used 3 numbers, 1 up to 3, that means 4 is not part of it. It can be any number continuously so. So even 4, it is integer. And just because of is positive, I can take it as positive. But we know the square root usually comes as plus or minus. You see, it always comes as a plus or minus. But now, for now, less, because we just know normally it's just 4. The plus or minus is something else. It is applicable on other stuff. Now, what about this? The irrational. Yes, it's rational, but it cannot be irrational. As you can see, this number, you just put 6, and now you are just having 4. That is still part of the rational. Now let's come to number 5. Let's come to number 5. Negative 5 basically. Now, for counting, can we use a negative number to count? Since N1 is natural and it's for counting, can we use a negative number to count? That is the question that you should ask yourself. Can we use it for counting, a negative number? Oh, my mic is failing me. All right, now let's see. I cannot use a negative number to count. It is still not part of the whole numbers. Because whole numbers, they've got no negative number. Now, coming to integer. Yes, integers, it take both negative and positive. So yes, it is still part of the integer. But is it a positive integer? No. Because it's a negative number. It's part of the negative integer. Now the question is based on the 2. Is it rational or irrational? Just like here we just had a 6. We said it can be irrational because it can be written in a fraction form. Also, this can be written in a fraction, negative 5 over 1. So I consider this as a rational, not as irrational. Now, let's come to E, the pi. I think this one, they're forever using it everywhere. If you punch your calculator, you will get 3,142, blah, 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 blah. Those numbers. Just like they gave you 4 in a form of square root of 16. Here they give you 5 in a form of 25 over 5. So here they also give, there's a number representing this pi, which is 3,142 and more numbers after that. But no matter what it is, like I'm saying, this is equivalent to 3,142, blah, blah, blah. This is continuous. You can tell that you cannot use this for counting, never. we cannot use this as a whole number to count as well. This cannot be part of the integers, whether integer, positive integer and negative integer. Never. It cannot be irrational. It cannot be irrational. Why? Why? If it's a decimal, for it to become irrational, it has to repeat and it end. So this one is a continuous, but there's no, like, it doesn't end, right? So it's either it end, then it shows that it is rational, or it repeat, it shows it is rational, but that is something else. It doesn't end, and yet it does not repeat. So it's a perfect example of irrational. Let's come to 18, square root of 18. I don't know what is the square root of 18. From your side, you can punch a calculator just to know what is the square root of 18. My calculator tells me that square root of 18 is 4,242640687, like just a whole lot of numbers. But the fact that I'm getting a decimal number with a lot of digits, that means I cannot use this for counting. I cannot use this, is still for counting. And then talking about z, z, they are all integers, but integers are either negative, positive, but not in the form of a decimal. So it cannot be this. Now, the argument can be between these two, rational or irrational. Like I'm saying, just check one of the characteristics. If it's irrational, that means the decimal cannot repeat itself, and it doesn't end. It's a number that has a lot of digits after the comma, but none of them whatsoever that repeat itself. So if you press the square root of 18, the number that you get, it doesn't end, it proceeds, but yet it does not repeat. So that is a good example for irrational, so it cannot be rational. Now 0, let's come to 0. Natural, they don't start with 0, so this cannot be a natural. But yes, it is part of whole numbers, and yet it is part of integer, because look at integer, they do have 0, so it's still part of it. But now, since it only accumulates, it cannot be this, it cannot be that. You can just look at the definition to make sense of everything. But I can check, we can verify some few stuff, especially when it comes to 0. Can 0 be a positive? Can 0 be a negative? Because it's just in between. Yeah. So that is something that we can look at. You see? All right, let's come to h. H, we are having 0,548. There's something obvious. We cannot count using decimal, never. Integers, they don't have decimal. All this, the argument is just between the two. Is it rational or irrational? Let's check rational. Rational, they say a decimal just end. So you can see 0,548, it end. It's not something that continue to have more digit after the comma. It just ends there. So if it ends there, it accommodates rational, not irrational. So you can always go back and forth. Imagine if you want to excel with this, if you want to excel here, just make sure that you master the difference between the two, because these three, they're not of a problem. The problem is only between the two. It's easy for one to confuse the two. Now, let's come to the last one. What does 25 over 5 give us? It gives us 5. 5 into 25 is 5. So basically, we can now work with 5, no longer 25 over 5. Is 5 part of natural numbers? If yes, let's check it. Is 5 part of whole numbers? Yes. Like we said, natural numbers can be 1, 2, 3, 4, 5. So 5 is still there. Whole numbers, you can say 0, 1, 2, 3, 4, 5. 5 will still be there. Integers, it takes their positive numbers and the negative. So since I've got 0, 1, 2, 3, 4, even 5 is still there. This means continuously. So it is still part of the integer. Though 5 is positive, so it's still part of positive integer, but it's not a negative. 5 is not negative, so it's not a negative integer. That's how we look at this. Now, let's check the last thing. Since we have got 6, which can be expressed as a fraction, that means even 5 can be expressed as a fraction. What does that mean? This is our rational, and it cannot be both rational and irrational. Now, this lesson, this is all I wanted to deliver for the grade 9s. We start here. Then from then I'm going to upload more videos on all these topics. I know this was the first one. Every time, for first time, this is what you are doing. So if you want to make sure that you understand everything that is taking place, make sure you watch this video till the end, and then subscribe for more videos. Hit the notification bell to be notified every time we upload. Comment, like, and share. Please make sure, let's communicate through the comment section. Whatever question that you may have, let's work on it through comment section below. I thank you for your time. God bless.